Today's video is going to be about the Pythagorean Theorem. We're going to start with what is the actual Pythagorean Theorem. You probably learned it as a squared plus b squared is equal to c squared, which is true, but we're going to go a little bit deeper into it, and we're going to talk about what is a, what is b, and what is c. We have talked about some different vocab words and what the different sides of the triangle are, and a is representing a leg of the triangle, and b is representing the other leg of the triangle, and we set it equal to c squared, which is the hypotenuse of a triangle. And we know that the Pythagorean theorem is only going to work if we have a right angle. So that's maybe something that you want to make a note of. Pythagorean theorem will only work if there's a right angle. And therefore you have two sides that are legs and one side that's the hypotenuse. The hypotenuse is going to be the side that is opposite of your right angle. So if we look at a right angle here, here's my right angle, here is the leg, here is the leg, and here is the hypotenuse. So let's go ahead and use that Pythagorean theorem to solve. Leg squared plus leg squared is equal to hypotenuse squared, so that's 8 squared plus 15 squared is equal to x squared. We can go ahead and plug all that into our calculator. 8 squared and 15 squared together, that's 289. Equals x squared. Now I don't want x squared, I just want x, so I square root each side, and we get x is going to be equal to 17. Now technically our answer is plus or minus 17, but because x is representing a side length of our triangle, we aren't going to write the negative 17 because it's not realistic. Alright, number 2, we've got leg squared plus leg squared is equal to hypotenuse squared. This time our x is on this side, so we have 5 squared, which is 25, 13 squared, which is 169. We want to isolate the x squared, so we move our 25 over, and we get x squared is equal to 144. Square root each side, and we get x is going to be equal to 12. All right, let's move on to number 3. Same process every single time. Leg squared and leg squared is equal to hypotenuse squared. So we've got 4 squared plus 10 squared is equal to x squared. And 4 squared and 10 squared together is going to give us 116. When we go to take the square root, we have a problem. We end up with x is going to be about 10.77. Your calculator is going to give us a decimal answer. That means that it's not a perfect square root the way we got in number 1 and number 2. You want to know the difference between your rounded answer and your exact answer. If I'm looking for the exact answer, and I do want you to know both, I'm looking at the fact that x is going to be equal to the square root of 116. We do a factor tree to break down 116, which is 4 and 29, which is 2 and 2, and 29 can't be broken down. So then we end up with that x is going to be equal to 2 square root 29. So we have a rounded answer and we have an exact answer. And I want to make sure that you are aware that you need to know both. You need to pay attention to the directions and see if I'm asking for rounded or if I'm asking for exact. Exact has radicals, rounded has decimals. Next one, we have again the leg squared plus leg squared is equal to our hypotenuse squared. X is on the side with a number, so we want to go ahead and simplify each of our squared terms. We move our 4 over, we get x squared is equal to 60. Once again, we see that we don't have a perfect square, so when we break that down, 6 and 10, 2 and 3, 2 and 5, we've got a group of 2's, which means on the outside we've got a 2. 3 and 5 left over. 3 times 5 is going to give us 15 on the inside. And then if we go to our calculator and just do the square root of 60, we get x is going to be about 7.75. Again, this is going to be our exact answer with the radical. The answer with our decimals is going to be the rounded answer, which is going to bring us to the topic of Pythagorean triples. There are triples that are used, and triples are when we have whole numbers. Whole numbers means we have no decimals, and those whole numbers follow the Pythagorean theorem. That is how we know it's a Pythagorean triple. Some people have you memorize these, It makes things a little bit quicker and easier. The most common Pythagorean triple is a 3, 4, 5 triangle. So if we have our triangle, this is 3, this is 4, and this is 5. 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 is equal to 25. 25 equals 25. So each of my three sides are whole numbers, and they follow Pythagorean theorem. So we want to check to see if the given numbers here are Pythagorean triples or not. So the biggest side is always going to be the hypotenuse. So we're checking, is 9 squared plus 12 squared, is that going to be equal to 15 squared? 9 squared plus 12 squared on our calculator gives us 225. 15 squared is 225. So this one is going to be a yes. It is a triple because each of my three numbers are whole numbers, and it's going to follow Pythagorean theorem. When I get to the next one, I don't even have to do any work. I can say no right away because I have decimals in my answer. In order for it to be a triple, I must have whole numbers. Let's check our last one here. We've got 8 is our hypotenuse because the hypotenuse is always the biggest side. So 6 squared plus 7 squared, is that equal to 8 squared? When we go to our calculator, 6 squared plus 7 squared is going to give us 85. 8 squared is 64. That is not equal, which means it does not follow the Pythagorean theorem. If it doesn't follow the Pythagorean theorem, then it's not going to be a Pythagorean triple. Alright, the last section of our notes for this video is trying to determine if it's a right, acute, or obtuse triangle. This next part is coming based on the Pythagorean theorem. We're going to use an inequality of the Pythagorean theorem to determine whether it's acute, obtuse, or right. Well, we know in the Pythagorean theorem, if a squared plus b squared is equal to c squared, we need a right triangle in order for that to be true. Now, what happens if it's not equal to each other, like before? We just had a problem right here, 6, 7, and 8. Our a squared plus b squared was not equal to c squared. We want to see what's happening there. We want to put the c squared first, so we want to have the hypotenuse first. If c squared is less than your legs squared together, then it's going to be an acute triangle. If your hypotenuse squared is greater than the legs squared, it's going to be an obtuse triangle. So above here, the hypotenuse is 64. That's less than the legs squared. So this right here would be an acute triangle. We want to always put the hypotenuse first when we list it, and that way it's easier. Less than is acute, greater than is obtuse. So we pick our largest side, which is 9. So we want to find out 9 squared. How does that compare to 3 squared and 7 squared? So we get 81 and 58. Since 81 is greater than 58, this is going to be an obtuse triangle, all based on having that hypotenuse first. So 5 squared, how does that compare to 3 squared and 4 squared? 5 squared is 25, 3 squared is 9, and 16 is 25. Because the hypotenuse squared is equal to leg squared, that's going to be a right triangle. And last, 10 squared, how does that compare to 8 squared and 9 squared? 10 squared is 100. 8 squared and 9 squared is 145. So the hypotenuse squared is less than the leg squared, which is going to make it an acute triangle. And the key to this one is putting the hypotenuse first, comparing the squares together. Alright, and we are all done with this video on Pythagorean theorem.